So some concepts that are entering the mainstream, okay? So things that started as like a permaculture concept and now is actually entering in our architects, engineering schools, people that are, they don't call it permaculture, but hey, they still do the technique. So this is called run on, not run off. So this is a bioswale in a parking lot. So then we start to see the parking lot as an ability to capture water to the swale to grow plants. Before, the parking lot took the water and they designed it to go to the street, to the gutter, and out to the river, right? But now, certain areas in the world, especially proactive states in the US, are making illegal. As an engineer or designer, you cannot let any water run off of your property. It's illegal. So you have to design the watershed of your building in order to capture all the water and put it into the aquifer. If you allow any water to go into the street, well, the street's public, right? You can't do that. Why can you take your waste and put it into the public? You can't do that. So they're switching the thing. It used to be we designed to push the water away. And now we're flipping the designs and we're designing to put the water down. Very different concept, and this is coming in through like years of people around the world pushing water harvesting. So here's our run on, not run off. So you can see where they cut the curb. So before they would have had this parking lot drain out to the road. But now it drains into the swale beds. So the parking lot is watering the, if you want to say beautification, the landscaping. So our landscaping being watered by our parking lots. So other things that are changing, they're actually not even changing they said, why should we even have the parking lot shed water? What if we use technology? So now they can make concrete called porous pavements. It's concrete, and if you pour a glass of water on it, it runs through. No water stays on top. Right out. Interesting. So it minimizes the pollutant load in our water. It helps recharge our groundwater aquifers. Remember, that was one of our biggest problems, that we were shedding all the water away to the rivers and the ocean, and we weren't letting it recharge. And it decreases any runoff because it's allowed to go in. So these are different types of porous pavements. Here's a diagram showing, so this is a concrete, so they can go in, they pour concrete. And if I take a glass of water and I pour it, it goes straight through. Doesn't hold the water. So now if we make parking lots or roads out of this, we can use the road as a water capture. I mentioned this to you guys when we were working outside. The solution to pollution is dilution. So this is now another subdivision. They built it around a gray water treatment. So all of the homes and the roads takes the water and it brings it to a wetland. So this is an artificial wetland designed into a spiral with terraces. So the gray water enters the first terrace, soaks through second, third, fourth, fifth, and by the time it comes out, it's clean. Then it's allowed to leave, right? Then they use that water, it's brought back, and they sprinkle, and that's how they water the grass. So they're taking the roads to clean the water, and then that's how you water your grass. So you're watering your grass from catchment. So this is changing how people design. And proactive people that may say care about the environment, they're now having the ability to say, if I have a good job, can I pay for living in a clean place? Can I buy a home in a subdivision that captures, cleans their water? Would you like to live in that subdivision or the one that doesn't? So we can see people now paying for this. This is a green building movement. We want to live in houses that are built well. We want to live in subdivisions that are storing their water better. So here's some rainwater harvesting. So people say, hey, wow, it rains. It's free water. So if I buy this at the gas station and it costs $3 for 1 liter, but I get this for free, why should I pay? So here, very simple solutions to put gutters, store your water from your guttering system into tanks, and then ask myself a question. If I can capture that rainwater, what can I do with it? What do I do with water that I've captured? One great way that's proliferating around the world is this concept of living roofs. So one is to go to an existing building that just had a concrete roof, captures heat. Our cities are known as heat islands. We have concrete, asphalt, and the heat reflects, and you look at the city, it's really hot. But if we went on top of every building and we put a garden, a living roof, that captures the heat, but the plants actually absorb the heat and lessen with humidity because they're using water. So the water harvesting of the building supports the living roof and it lowers the temperature. So we can reduce stormwater runoff because the water doesn't run off, it goes into the garden. We have better quality water, so any water that filters through the soil comes out as clean. It extends the lifespan of the roof, okay, because it's insulated. We can reduce the sewer costs because they'll take any excess water and use it in the sewer system on site. They improve the air quality of the city. It reduces the noise level, so the person living on the top can't hear because it's insulated. And it improves the aesthetics. People would like to live in that building. So now I have a park on the top of my building versus ugliness. Very simple solutions. A gray water irrigated orchard. What does that mean? You guys been taking a shower, right? Where do you think the water goes after you take your shower? You stand on the rock, and the water goes down, right? So that then supports the irrigation. So your water goes back basically to the pond. We're irrigating, and then we use that water, so any excess that you're not used, right, is being recirculated. Same if you brush your teeth and you use the sink, it goes into the flower bed. So any excess supports plant growth. These are concepts. So here we can see, very simplified, there's a laundry. When the person is doing their laundry, the excess water falls onto the ground, and a little streamlet brings it to a coconut, and then they get coconuts. So any excess laundry, if I make my laundry, if I take a shower, if I brush my teeth, if I wash my hands, where does the water go? Do we put it in the sewer? Out of sight, out of mind? Or could we take that water, which is not necessarily dirty, and could we use it? So this is what we want to look at. So this is a shower and or laundry that they have a hard packed surface. They could put stones, and they bring that to their coconuts, and they grow coconuts every time they take a shower. Gray water irrigated orchards, again, very simple. It's in India. The lady does her laundry. They use their toilet. They then bring the water, excess, next to all of their things. So here's a banana circle. So any excess water that soaks in, the bananas take. If there's excess, it keeps going to the next one until finally there's no water. The plants have taken up all the water. And if you do this well, this lady harvested from her garden, just from excess water from taking her shower, a 4-kilo papaya, just with gray water irrigated trees. And the tree that's next to it that doesn't get any gray water irrigation didn't yield any papayas because it's too dry in this location. So she got not just the sanitary conditions, she's cleaned the water through the cycle, and she generated a papaya which you can eat. So this gives a concept, this concept of gray water systems. How do I look at my home and understand that my home's like a spaceship, right? It's my spaceship. It can bring me where I want to do. It should be able to take care of it. Why doesn't my home provide for my energy? Why doesn't my home provide my water? Why doesn't my home clean its waste? Why do I have to pay for all those services? Shouldn't my home do that for me? So here, whole house gray water system. I take my shower, I wash everything other than black water, which is your feces. That goes to a tank, right? And then I could use that to, say, sprinkle my lawn. There, if you were in a very proactive place, so in Texas, there's a place called Austin, Texas. They've passed laws that says everybody that lives in Austin, it's illegal. You cannot water your grass with anything other than gray water. If you don't pay to put in a gray water system, your grass can die. So you either put in the system, and it's illegal to water your grass with drinking water or like city water. Can't do that. You can save your water and water your grass. That's what you can do. And this is where our proactivity comes in, to where at a local level, we can make change. In our own city, we can get people to vote for local ordinances. So whether the government wants to change something, we can change it locally. So in certain proactive places like Seattle, they have the same thing. They call cut the curb. So they said, why do we have our roads and they have curbs that doesn't let the water go? So you have the right to go and cut the curb with a saw to take the water from the road for your usage. And they passed a law, says that's your right. So this brings us to this concept again, these earthships. How could I have my home do everything for me? All the functions of my house can be performed in an earthship. And this comes into what's described as water management. And when we do our permaponics day, how can we use water to grow our food? How do we use soil to clean water? So here we see a model, if you will, infographic, of how water is used in an earthship. And when it goes through what can be known as a biological filter, all right, a biofilter. The biofilter, utilizing coarse rocks, sands, chars, and will filter the water to come out as clean, and an added benefit, it grows food. So these are interesting systems. So here's a diagram of what an earthship would look like. It's the concept of bringing the garden or your greenhouse into your house. So now I have a greenhouse attached to my home. All of my water is circulated through my greenhouse. There we see the front of an earthship, and that's how this concept of don't let the water go out. The water is valuable. The water can grow food, right? And we should clean our own water. We shouldn't put it to someone else to do that. Another concept, people had swimming pools. Anybody, parents have a swimming pool? Yeah, well, sometimes that's a lot of water usage, and then people don't even use it. So I know when I grew up, my parents had a pool. By the time I think I was about 12, 13 years old, we never went swimming. I think I could count years, a whole year, I never one time went in that swimming pool. Nobody went swimming in it. It was just there. So what if we drained it, and when we made a little koi pond, and then we used that? So this person has drained the swimming pool, put in a little koi pond, and he's circulating that water with the fish, and he put his garden in his pool. A pool garden. There's a little simple info diagram. He put a polytunnel over the top of the pool. He put his chicken coop inside, hanging over the koi pond. So when the chickens poo, the poo falls to the fish. The fish poo, they take the water, and he grows his plants in his backyard. So instead of having to pay someone to clean your pool or buy chemicals and things, right? And if no one was using it, he makes a garden in his pool. These are called rain gardens, the concept that if I can harvest water from my gutters, right? Where does the water go? If I can direct the rainwater, at that point, I can make gardens. So every time it rains, I'm directing the water to a particular garden. So here we see rain gardens and how they may work. So quite interesting. And this brings us a bigger concept of a living machine, right? How do we create, if we can make these into a full size? So y'all saw my septic tank, right? I said it was a living machine, but it's quite small. What if I made one big enough to take a whole town? So this is a sewer plant. So instead of using chemicals to clean our waste, people are now using biological, right, animals, if you will, systems, biological systems to clean waste. And what's the best thing about this is not just that we get clean water. We also get the added benefit of growing food, okay? So our nutrients can be re-put back into our food system, not flushed down the toilet and go to the ocean. Because currently what we're doing is taking minerals from the land, and then we eat it, we flush it down a toilet, and we put it into the ocean. The minerals are lost, right? So we're demineralizing our soils. At the same time, we're wasting them. So that's one way we can look at living machines. And a natural swimming pool can be a great way to also conserve water. So if I have excess water, I can fill up this natural swimming pool. So this is a very simple thing. We use that same biologic filter, but if we don't put waste like poo in it, we just put regular rainwater, right? Then we can create a natural filter that allows me to swim in my pool, and my pool's clear, it's clean, without chemicals, right? So this concept where people are saying, why do we have to clean water with chemicals? Why can't we clean water naturally like nature does? Nature doesn't use chemicals to clean water, and it does a really good job. So as designers, if we can mimic nature, we can look at how nature does things, right? Permaculture is saying, I'm not that smart. I'll just copy nature. I'm smart enough to do one thing, right? Look at how nature does something and do my best to copy nature, because if you believe in Gaia theory, which I do, she got it right the first time, right? So we don't need to do these things. It's when we don't follow nature that we create pollution, we create waste. So this is a cool one. A permaculturalist did this. I think it's kind of interesting. They have a hill at their property, and on the top of the property they put a swale. And the swale is a speed bump, and it captures the overland water flow, right? Cool. They diverted the speed bump of the swale to these water tanks. So now up at the top of their property they have these two water tanks. So the big swale catches the water, brings it to the water tanks, and they have a pipe coming to their house, and guess what they have? Pressurized water. So the swale acting as a catchment to fill their water tanks so that they can have water for their garden. So when they go to their garden and they turn on the tap, they don't have to use electricity. They use gravity. So if we can have property that has elevation and we can capture water at height, it's like having a battery. It's free energy. So we need to start to think about water as what water actually is. Water is energy. If we can capture energy, we can use it, right? So the more energy capture I have, think about solar panels. If I have more solar panels, I can do more things, right? And if I have more water, I can do more things. So if I have sun and water, now I have access to do things. So look at capturing water, and this is a great way that they did it. So Bill Mollison, basically a great quote from the designer's manual, he said, you know, if you really get into looking at a forest or a jungle, what do you actually see? Each tree is comprised of water. The tree is a pump. It's pumping the water from the ground and pumping it into the air through transpiration. So actually all the water mass that's in the trees, right, you could even consider that it's a lake. If you measure the amount of water that's in the biomass, it's like having a lake, and then that lake pumps up and makes its own rain, and it circulates the rain. So when we call it the rainforest, what's going on, right? The rainforest is basically a huge lake that is transpiring and pumping its own rain. So it's creating rain, which is interesting. In certain instances, if we have overland water flow, we can create what's called an overflow pond. So this would be an area that when there was too much excess water, we'd allow it to accumulate, soak in, and then it would not be a pond normally, just for overland. So we slow the overland water flow, because if water comes on my property and I allow it to go down, and then you do, and you do, and you do, and you do, and all of a sudden there's a flood. So this person's getting flooded because everyone up here won't slow the water down. So if we would slow the water down, we could stop flooding at, say, lower elevations. This would be a concept that we could think about. How do we do that in especially a dry land situation? This is a technique called a gabion. Very simple. I put some post and I put wire. Same type of wire. It could be chicken wire. It could be wire that they use for putting in cement floors, any type of wire. And then I can stack rocks. So I've made basically a dam. In this instance, what happens is when the overland water flow comes, it hits the rocks, right? And the rocks are strong enough to make it slow down. When the water slows down, it drops to sands and silts. They have time to fall down, right? So after a period of time, the water keeps hitting this, and it creates what's called a sand dam. The sands and silts back up behind the rocks. So then every time the water comes, it soaks in, and guess what you can do right after the rain? Plant your seed. You got enough water captured in the sand dam. So in really dry or deserty conditions, simple things like gabions allow you to slow down the water flow to catch the sands and silts in order to grow vegetables in places where there's not a lot of rain. We can even look at large-scale hydropower. Okay, so here's a pumped storage plant. Very interesting. Basically, they have a reservoir sitting up high. They put a pipe. The pressure of all that water runs a turbine, right? And it creates electricity. So that's another great thing. The same city, Austin, right? They all voted locally to be taxed. They said, we want to produce our own electricity. So they built one of these. And so the city paid for it, and then they taxed everybody on the usage of the electricity, and then basically the whole city's off-grid. So not only can't you water your lawn with drinking water, you have to be off-grid. It's a really proactive place. So we have these places in the world, whether it's Seattle, all over the world, it's popping up, where people are saying, hey, I'm tired. I want to go move with other people who think like me. And we can all together vote, and we can do things. So we have access. So this is large scale. We can do it if we can vote together, locally especially. There's medium scale, so a small community could do something like this, divert some water from a stream and create hydro. This would be enough to, say, support a whole village. You see this all over. And even on a small scale, if you have running water on your property or elevation change, you can put in what's called micro hydro. I've even seen one on the internet. Technology's moving very fast. But just to demonstrate what we could do. So we have the gutters, and the water comes down the gutter, right? If I put a computer fan from a desktop computer in the gutter, right? And then the water went down, it would turn the fan, right? And it would make electricity. Yeah. What if I put 1 fan, 2 fan, 3 fan, 4 fan, 5 fan? So if I made a waterproof computer fan, which is easily to do, right? We have the technology to do that. So then every time it rains, it makes electricity because gravity flows. So it's almost infinite the amount of electric that we can actually produce. Do you know in every city around the world, if you turn on your tap, because the water is under pressure, right? So when I take a shower, the water is moving through a pipe. Is that correct? All around the world in every city. What if I just went and I cut that pipe and I put in a fan and the water went by and turned the fan? What would it do? make electricity, and what if I put another fan and another fan and another fan? Electric, 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 electric. So think about the opportunity just to put turbines in existing water systems. Oh, and by the way, they already have companies that do that. So these are things that are already taking place. The future of how we're going to get energy's unlimited. The amount of energy that comes from the sun in a single day, guys, is infinite. We can't even really understand how much it is. So if we only had solar panels in the state of Arizona, in the US, we could power the entire world. That's it, with today's technology. The problem we have is distributing the electricity. So we have an infinite solar, but we have distribution problems. So whether it's energy, food, or water, we need to focus on distribution. And one of the best solutions is to do things locally. For local communities to be empowered to take care of their own energy, their own water, and not to have to buy things through transportation.